Very good evening, guys. Very good evening, very good evening, very good evening. I hope you people are doing fine. I hope your preparations are at full thrust. Good evening, Minachi Sundaram. Minachi, what is the meaning of thala? Is it that tune like thal means like I think thal means right tune, right? Does thal means tune? Okay, so let us start the session without wasting any more time. So for those who don't know me, my name is Manish Mishra. I secured an All India rank of 568 in GATE 2015, and since then I have been teaching for GATE and ESE. I have a cumulative experience of 5 years now, and the subjects that I primarily take are manufacturing, industrial operations as well as material science. Pavit Ram, hi to you too. Pavit, I think this is your first lecture live with me. Okay, Minachi, now I got the meaning of thala. Pavit, I think this is your first live lecture with me. So guys, let me tell you that I am currently running a series by the name of Manufacturing 2020 on the Unacademy special classes, which is absolutely free, where in 20 days time I am basically targeting the entire manufacturing, which can help you guys fetch 20 marks in the GATE examination. So I started this series on the 10th of December. 10th of December, and every day I go live from 9 a.m. to 11 a.m. in the morning, just for 120 minutes every day, 2 hours. So if you want to watch these lectures, feel free to use this code MMM10 to unlock your free plan on the Unacademy app, and then you will be able to watch these classes for absolutely free. Okay? Good evening, Ashwin. Good evening, good evening, good evening. So this is the entire schedule of Manufacturing 2020, my friends. We started on 10th of December with casting, then on 13th of December with conventional machining, then on 19th of December with unconventional machining, then on 20th of December with welding, 22nd December with metal forming, and right now, my friends, today I started with metrology. And I will be ending metrology tomorrow, and then I will be starting computer integrated machining. Correct? So if you want to join this session, go ahead. You can simply watch these classes by searching my name Manish Mishra on the Unacademy app. So if you have downloaded the app, my friends, you can straight away go to the special class category and can search my name Manish Mishra. This profile will appear. You just simply have to follow me, and then all the notifications of all my classes will be coming to you. Okay na? So friends, I am a verified educator at Unacademy, and I have a rank of 95 among 1000 plus educators in the GATE and ESE category. Correct? And my friends, I have achieved this milestone just in 30 days time, which would not have been possible without the love and affection of you guys. So guys, you can simply even scan this QR code using your mobile phone camera also, and then you will be able to watch my classes. Okay? Just scan this QR code using your mobile phone camera, and that's it. One more thing, guys, when you will want to watch these special classes, the app will give you a prompt that enter an invite code to unlock your free plan. In that section, just simply use the code M10. So M10 code will unlock your free plan on the Unacademy app, and then you will be able to watch all the special classes for free, right? Guys, this is the Telegram group chat that I have created. It has already surpassed 130 members right now. And in this very group, my friends, I share my notes, I share practice booklets of various subjects, I share notifications of my classes, guidance, and many more things. And one more thing, it is a two-way group. You can even post your doubts and we can have certain discussions also if you would feel like. If you want to join this Telegram channel, simply scan this QR code using your mobile phone camera, and that's it, my friends. You will be able to join this group, and then you can enjoy the benefits of this Telegram group chat for absolutely free. So okay, let us start today's session. Let us start today's session of Industrial Engineering and Operations Research. In the last class, my friend, in the last class we were discussing transportation problem, and in this transportation problem chapter we have completed the stage 1. We have completed the stage 1. So what is the stage 1? Remember, we were discussing about the solution procedure of transportation problem. So solution procedure of transportation problem basically have two steps, step 1 and step 2. Step 1 was to find the initial basis feasible solution, and step 2 was to perform the optimality test. Correct? So basically in the last class we were dealing with the methods to find the initial feasible solution, that is stage 1, and we basically looked at all the 5 methods. We took one question and we solved that very question using all the 5 methods and obtained 5 different feasible solutions, right? So through the northwest corner method we have obtained Z equal to 650, transportation cost is 650. Through the row minima method we have obtained again 650. Then my friend, through the column minima method, we have obtained Z equal to 750. Then through the least cost method or the matrix minima method we have obtained Z equal to 630. And at last, my friends, using the Vogel's approximation method or VAM method, we have again obtained Z equal to 630. Correct? So I have already explained this in the last class. Those of you who have not watched my last class, please go and check out that session, and then only you will be able to continue from this lecture. I hope you are getting my point, right? Now, listen to me. Okay. At this moment, my friend, we have used all the 5 methods to obtain feasible solution. ठीक है ना? We have not yet obtained an optimal solution. It is yet to come. We have obtained feasible solution. Now the objective was to minimize the transportation cost. So if the objective was to minimize the transportation cost, then if I will look at all these 5 feasible solutions, then basically this 630 from the VAM method and this 630 from the least cost method or the matrix minima method. These two solutions, my friend, these two solutions are, I would say, the best feasible solutions of the lot, because they are the most minimum. I mean, we have 750, we have 650, and then we have 630. So 630 is the minimum of the lot. I hope you people are getting my point. 630 is the minimum of the lot. And if the objective was to minimize the transportation cost, then definitely 630 is the best feasible solution that we have obtained from all the 5 methods. Now, my friends, the idea is that whatever feasible solution you have obtained, I mean, whether you have obtained 630, whether you have obtained 750, or you have obtained 650, you can take any of the solutions, and perform the optimality test of that feasible solution. Remember, in a linear programming problem method, what we used to do, after every iteration, we used to calculate Cj minus Zj. After every iteration, we used to calculate Cj minus Zj, right? And through Cj minus Zj, we basically used to check whether that particular iteration is an optimal solution or not. I hope you people are getting my point. So through simplex method, the idea was to obtain a feasible solution and then perform the optimality test that whether that feasible solution is the optimal solution or not. So basically, my friends, we have done the stage 1 where we have obtained the feasible solution. Now we have to check that whether one of these feasible solution is optimal or not, right? But the thing is that if I have 650, if I have 750 and I have 630, the same feasible solution, sorry, the feasible solutions for the same problem, the feasible solutions for the same problem we have as 650, 750 and 630, then basically it tells me that 750 and 650 are not feasible solution at all. Sorry, are not optimal solution at all. I hope you people are getting my point. Guys, if I have 630, 650, 750 as my feasible solution, then if 630 is present, which is more minimum than 650 and 750, then 650 and 750 cannot be optimal solution. 650 and 750 cannot be optimal solution. I hope you people are getting my point, right? So the idea is that if you have obtained the value 630 as the feasible solution, the best thing to do is to perform the optimality test of 630. To perform the optimality test of 630. Because remember, 650 and 750, we already know they are not optimal. So the best thing that you can do is take that feasible solution, which is the minimum of the lot, and perform the optimality test for that solution. I hope you people are getting my point. I hope you people are getting my point, right? Now, what is the optimality test? What is the optimality test? So guys, the optimality test is basically the stage 2. It is also known as Modi method or modified distribution method, correct? So basically what the optimality test says, that to perform the optimality test, the number of allocations should be equal to m plus n minus 1, where m and n are the number of rows and columns respectively. If the number of allocations are less than m plus n minus 1, then the problem is said to be degenerate. Don't worry guys, I am reading it out for you and then I will be explaining each and everything to you, correct? To obtain optimal solution or to perform the optimality test, an allocation of epsilon is required at the independent position. If more than one independent positions are available, then epsilon can be added to the cell where the cost is minimum. Correct? Now, let us understand what is the meaning of this. Let us understand what is the meaning of this. So basically, let me just take you through all of this. We had one question, a transportation problem. First of all, we checked whether that transportation problem was balanced or not. If it is balanced, then we basically perform the stage 1, that is to find the feasible solution. We obtained 5 feasible solutions through 5 different methods, and the idea is that out of these 5 feasible solutions, the minimum value of the total transportation cost coming from which solution, you take that solution and perform the optimality test for that solution, correct? So that is the basic intention. Are you getting my point or not? Are you getting my point or not? I hope you guys are. Okay. So guys, now 630 from the Vogel approximation method and 630 from the least cost method. These two are the minimum feasible solution that we have. So we have to take either one of these and perform the optimality test. But what I am going to do, I am not going to take either of them. I am going to take 750. 750. Because I want to explain to you guys how the optimality test works. Otherwise, I would have easily taken 630 and it would have straight away told me that it is an optimal solution. But I am not going to do that. Let us take 750. Okay, let's not take 750. Let's not become hero. So let's take 650. Okay, let's take northwest corner method feasible solution 650, and let us perform the optimality test. Because I know that 650 is not optimal. So the optimality test will straight away prompt me that this is not an optimal solution and you will have to further optimize it. That's why I'm taking 650. But remember guys, I'm only doing this to explain the optimality test to you. Otherwise, there is no need for me to take 650. I would have straight away taken 630 and performed the optimality test. It would have been a wiser choice, because if 630 is present, then I already know that 650 is not optimal. I am taking 650 because I want to explain this to you guys. So don't even think like the solution is very big, the optimality test is very hard. Don't even think like that. Okay, na? Remember, 630 you would have chosen, but I am choosing 650 so that I can explain to you guys that how the optimality test functions, right? So optimality test. So I am taking the solution of the northwest corner method. So the northwest corner method, my friends, have given me the solution 2476 5321 1476. So the solution is basically 20 30 20 20 10 50, 20 30 20 20 10 50, 20 30 20 20 10 50. Correct? So this is the solution that we have. Now these solutions, that this particular cell is getting 20 units, is basically called as allocations. Now suppose you have 5 chocolates and you distribute those 5 chocolates equally among 5 different children. So that is basically distribution. But suppose I have 5 chocolate and there are 5 children in front of me. So I decided I should give 4 to one student and 1 to another student. So that is allocation, right? That is allocation. I choose that whom I should be giving and whom I should not be giving, right? So that is the meaning of allocation. So guys, check this out. Okay, we have this solution. These are basically our allocations. So right now, how many allocations I have? 1, 2, 3, 4, 5, 6. The optimality test says that count the number of allocations. So the number of allocations that we have is equal to 6. Now it says count the number of rows and columns. So there are 1, 2, 3 rows and 1, 2, 3, 4 columns. Correct? So now it says that calculate m plus n minus 1, where m is the number of row, n is the number of column. So this is basically 7 minus 1, which is 6. Then it says that if the number of allocations is equal to m plus n minus 1, then you can proceed with the optimality test. And if it is not, then the problem is said to be a case of degeneracy, or it is a degenerate problem. Now what is the meaning of degenerate problem? You don't worry about that. I will be explaining each and everything to you. Just with patience, sit in the class, concentrate, right? Because this is very important. Highly analytical. Now my friends, now why basically I am being told that m plus n minus 1 should be equal to number of allocations. Why? You will get an idea. Okay? You will get an idea that why I am saying this. Okay? So now guys, what we have to do, this is our solution. This is our solution. So I will be making one more matrix. Okay? We could have solved everything on that matrix only, single matrix only, but let us take one more matrix for convenience. So 2, 4, 7, 2, 1, 6. So guys, now what I am doing, I am only writing the coefficients. I am only writing the coefficients of those variables which have allocations, correct? I mean, this does not have any allocation, this does not have any allocation, this has an allocation and it has a coefficient 2, so I am writing the coefficient 2 here, correct? Now I will be writing u1, u2, u3, v1, v2, v3, v4. Now these u1, u2, u3, v1, v2, v3, v4 are basically variables. ठीक है? Keep on listening. They are basically variables. And now my friends, we have to calculate the value of these variables. Guys, just wait 1 minute. I need to put up a slide in order to explain something to you guys. Okay. Now, hi Gino. Hi my friend. So, u1, u2, u3, v1, v2, v3, v4. This is what we have written, right? Now these are the variables. So there are 1, 2, 3, 4, 5, 6, 7. 7 variables are out here and we have to find the values of these variables. Now remember my friends, if you have 7 variables, you basically need 7 independent equations. If we have 7 variables, we basically need 7 independent equations to find the value of these variables, correct? Now how to find those 7 independent equations? Now the method basically says that you can take any variable as 0. Out of these 7, just take any one variable equal to 0. So you can take either u1, u2, u3, v1, v2, v3, v4, any variable you can take 0. Let us take u1 as 0. Okay? Now basically it says that using these values, these cells, the coefficients that are present in these cells, we have to formulate equations. So this 2 is basically at the intersection of u1 and v1. So I will be writing u1 plus v1 is equal to 2. Similarly, I will be writing u1 plus v2 is equal to 4. Then I will be writing u1 plus v3 is equal to 7. Then I will be writing u2 plus v3. u2 plus v3 is equal to 2. Then I will be writing u2 plus v4 is equal to 1. And at last I will write u3 plus v4 is equal to 6. Correct? So guys, now you can see that we have basically 6 independent equations out here. 6 independent equations out here, and because we have taken u1 as 0, we have only been left with u2, u3, v1, v2, v3 and v4, and using these 6 independent equations, I have to find the values of these 6 variables. So now I will be doing that. Guys, I am only drawing these matrices so large and so many times so that I can explain you. Okay, na? You could have done that all in one matrix. So 2, 4, 7, 2, 1, 6. 2, 4, 7, 2, 1, 6. So now basically if this is 0, right? So I can write 0 plus 2. 0 plus 2 is 2. 0 plus 2 is 2. So this is 2. Then I will be writing 0 plus x equal to 4. 0 plus x equal to 4. So this, my friend, is 4. Then I will be writing 0 plus x equal to 7. So this is going to be 7. I hope you people are getting the point that I am doing here. Okay, na? Now if this is 7, if this is 7, my friends, so I can write x plus 7 is equal to 2. X plus 7 is equal to 2. So here I will be writing minus 5. Then I can write minus 5 plus x equal to 1. Minus 5 plus x equal to 1. So this is going to be 6, correct? Then at last I will be having this plus 6 equal to 6. This plus 6 equal to 6. So this is going to be 0. Okay? So I hope you people are getting this. I have found the value of all these variables. Now what I am going to do, my friends, now what I am going to do here, I am going to make another matrix. Going to make another matrix, and in this matrix I am going to write the values with the help of these variables at these positions, these red marked positions. So basically these positions are those positions which does not have allocations, Suppose my friends that these are Maggies, like this position has 20 Maggie, this has 30 packets of Maggie, this has 20 packets of Maggie, this has 20 packets of Maggie, this has 10, this has 50 packets of Maggie. So now what we will be doing, because these places already have Maggie, and they have very particularly told us that Z is equal to 650, because remember I have taken the northwest corner feasible solution, and for that Z is equal to 650. So I have already found the feasible solution, and I know that transportation cost is 650 if we are keeping 20 packets of Maggie here with respect to 2 rupees, if we are keeping 30 packets of Maggie here with 4 rupees, 20 packets of Maggie here with 7 rupees, and so on. Correct? Now my friends, what I am basically doing, remember the simplex method? In simplex method, inside the iteration table, the variables which are under the basis column, in simplex method in an iteration table, the variables which are under the basis column were called as basis variable, and those basis variable, they had a value in B column, small b column was there, and these basis variable, they had a value in those B column. I hope you people are remembering that point, right? Because basis variable were the tables, were the variables which were inside the table, and they had some values in B column. And there were variables which were not inside the table, they were called as non-basis variable, and basically non-basis variables have a value 0. I hope you remember. Because guys, I expect you all to remember, hai na? Exam is very near and you must keep on revising certain things. We have just completed that topic, at least remember this much. All I am saying is that in the simplex iteration table, there was a basis column. The variables which were there in the basis column, they had a value in the B column, like 10 or 20 or something. But those variables which were not inside the table were called as non-basis variable, and their value was basically 0. Now the entire idea was to calculate Cj minus Zj. The entire idea was to calculate Cj minus Zj and check that out of those variables which are not basis, which are not in the table. Remember the example of Dhoni and Kohli. Rohit Sharma and Shikhar Dhawan were batting. They were basis variable. They had a value in B column. But Rohit Sharma, Shikhar Dhawan, although were inside the table, but then Virat Kohli and Dhoni, which were outside the table, they were saying that if you will let us go inside and bat, we can maximize the team score. I hope you people are getting my point. So idea is that if we can calculate Cj minus Zj, it will tell us that which variables which are not basis variable should be inside the table, should be getting the packets of Maggie, so that we can decrease the transportation cost. I hope you people are getting my point here. All I am saying is that these positions which do not have any Maggie, they are non-basis, they have 0 values, but I will have to check whether one of these variables can be Dhoni or Kohli, and they should be given the Maggies that I have already given to these variables, so that the total transportation cost that I have can further decrease, can further minimize. So guys, these positions which have Maggie, they are the basis variable, and these ones which do not have Maggie are the non-basis variables. So guys, in this matrix, these dash positions in red color are the non-basis variable. Now I will be checking for the non-basis variable. So guys, now I will be calculating Zj. I will be calculating Zj. How to calculate Zj? This is 0, this is 6. So 0 plus 6 is going to be here as 6. Minus 5, 2. Minus 5 plus 2. Minus 5 plus 2. Minus 3. Minus 5 plus 4. Minus 1. 0 plus 2. 2. 0 plus 4. 4. 0 plus 7. 7. So guys, these are the values of Zj. These are the values of Zj. But remember, in order to check for the optimal solution, I need Cj minus Zj. So let me calculate Cj minus Zj now. Let me calculate Cj minus Zj now. Let me calculate Cj minus Zj now. Now this is Zj, but what is Cj? This is Zj, but what is Cj? Arey yaar, this is Cj, coefficient matrix. Cj means what? Coefficient of variables in the objective function. Coefficient of variables in the objective function. Guys, yesterday in the starting of the class, I have clearly shown this to you. I have clearly shown this to you that this is variable x11 and the objective function is 4x11. So this 4 is basically the coefficient of the variable in the objective function. Right? Right? Are right or right? Are right or right? Now, Cj. Okay, Cj. So these are the values of Cj, right? These are the values of Cj. So now this is 6, this is 6, 6, 6, 0, minus 3 here, 5 here. So 5 minus minus 3, 8, 3 minus minus 1, 4, 1 minus 2, minus 1, 4 minus 4, 0, 7 minus 7, 0. Now my friends, this is what I am getting as Cj minus Zj. This is what I am getting as Cj minus Zj. Now remember, this is the transportation problem, and for transportation problem the objective is minimization. For transportation problem the objective is minimization. So guys, if the objective is minimization and in Cj minus Zj I am getting one variable as minus 1, then what is the meaning of this? What is the meaning of this? Guys, it simply means that this solution that we have, 2 to 20, 4 to 30, 7 to 20, 2 to 20, 1 to 10, 6 to 50, total 650. This solution is not an optimal solution. This solution is not optimal. Why? Because in Cj minus Zj, my friends, I have one negative value. This variable is basically saying, the variable x31 is saying that if you will allocate more packets of Maggi to me, transportation cost can be further decreased, further minimized. I hope you people are getting my point. So guys, x31 is basically saying that if you will give one packet of Maggi to x31, it will reduce the transportation cost by 1 rupees. Remember Cj minus Zj corresponding to Dhoni we had 4. So Dhoni was promising that if you will let Dhoni to play one ball, he can score 4 runs. So here this variable x31 is saying that give me more Maggi. If you will give me one packet of Maggi, I will reduce the transportation cost by 1 rupees. I hope people are getting my point. I hope you people are getting my point, right? चलिए आगे बढ़ते हैं. So guys, the thing is that I have not learnt anything new. Why? Why I am saying this? Arey yaar, I am saying this because I already had 630 and I am basically taking the optimal solution of 650 so that I can make you guys understand about the optimality test. Right? I already knew this. You already knew this. We have proved using the optimality test that through Cj minus Zj, because we have obtained one negative position, our solution is not optimal. Now what? Now this very optimality test, this modified distribution method will basically guide us that how you can obtain the optimal solution. For that, what I will be doing, I'll show you what I will be doing. So now, the thing is that this positions wants Maggie. Now let me write another table so that I can explain everything to you guys. I am making these many tables just to explain you, ठीक है ना? So don't think like, oh my god, इतना बड़ा solution, this big a solution. Don't think like that. So the solution we had was 20, 30, 20. 20, 10, 50. Correct? Arey yaar, I have to write this here. 20, 30, 20, 20, 10, 50. ठीक है? Now listen to me, guys. Now listen to me. This is the cell where I want to place more Maggie. Suppose I write that I should give plus X Maggie to this place. To this position, I should be giving X units of Maggie. I don't know the value of X right now. What I do know is that this place deserves Maggie. It can reduce or minimize the transportation cost. So now I have taken plus X here. But guys, what happens if I have given plus X packet of Maggie to this place? The thing is that whatever Maggie I had, I mean this is my supply 70, 30, 50, total of 150 packets Maggie I had. Now I had given 20 units here, 30 here, 20 here. So total 50, 70 plus 30, 100 plus 50, 150. So I had 150 packets of Maggie and I had already given those 150 packets of Maggie to other different cells. Let's say these are shops and I have already distributed 150 Maggie, allocated 150 Maggie to these 6 different shops. But now this one shopkeeper is promising me that he can further reduce my transportation cost. So I will have to definitely give him some Maggie. So I have decided that I will give him X packet of Maggie. I don't know the value of X right now, but I have decided I will give X packet of Maggie to him. Now if I have already allocated 150 Maggie and if I am saying I will give him X, then definitely I will have to take these X packets of Maggie from these positions from where I have already kept Maggie. I hope you people are getting my point. If I want to give X packets of Maggie to this position, then I will have to take X packets of Maggie from these positions where I have already given Maggie, because I do not have any Maggie. I have already allocated 150 packets of Maggie to other shops. But now I want to change my decision. So to whom that I have given the Maggie, I will go to them and I will have to recollect some Maggi from them so that I can give that Maggi to this cell, which is promising me more minimization of transportation cost, right? Now, the thing is, my friend, that if I have written plus x here, then 20 plus x, suppose you take the value of x equal to 10. Suppose you take x equal to 10. Suppose I have given 10 packets of Maggi here. Then this 20 plus 10 will become 30. This 20 plus 10 will become 30. But this go down can sustain a maximum of 20 units only. This go down can sustain a maximum of 20 units only. I hope you people are getting my point, right? Guys, I don't know whether my arrow is visible or not. I don't know whether my arrow is visible or not. This is a situation because I cannot see the arrow on the other screen that I have. So I cannot see the arrow, right? Okay. Okay. Let me use the rubber. Let me use the rubber to explain this to you guys. I believe you can see the rubber on the screen, right? Yes. So all I'm saying is, my friends, that I am basically giving this place 10 units, x is equal to 10, and this is 20. So 20 plus 10 will become 30, but this go down can only sustain a maximum of 20 units. This go down can only sustain a maximum of 20 units. It cannot sustain 30 units. I hope people are getting my point. Now, if I am giving 10 packets of Maggi to this place, then I will have to take 10 packets of Maggi from this place. If I am giving 10 packets of Maggi to this place, I will have to take 10 packets of Maggi from this place. I hope you people are getting my point. So now I will have to write minus x here, right? But guys, if I am writing minus x here, 20 minus x, which is 10, 20 minus 10, 10. So 10 plus 30, 40 plus 20, 60. But this factory was supplying 70. So now this factory is disturbed. Earlier this go down was disturbed, now this factory is disturbed, right? So if I am giving minus x here, I am taking 10 packets from here, then definitely I will have to give 10 packets to one of these positions, or 5 to each of these positions, whatever required, but I will have to distribute the rest of the 10 to either of these positions, so this 70 can be balanced. But if I will add, let's say, 10 here, then 20 plus 10 will become 30, and 30 plus 20 will become 50, but this go down can sustain a maximum of 40. All I want to tell you is, my friends, all I want to tell you is that if you change the allocation at any one of the position, if you are giving Maggi to any one of the position, then the entire solution will change. The entire solution will change, my friend. We will have to reallocate, redistribute the Maggi at this position, redistribute the 150 packets of Maggi at this position. That will give me a different solution, a new solution. Because the optimality test has already told me that this solution is not an optimal solution, and it is guiding me towards a different solution, which will be an optimal solution. I hope you people are getting my point. I hope you people are getting my point. Now what? Sir, आगे भी तो बोलिए. Sir, please say some other words. What is now? So let me just rub these. Let me just rub this, and then I will be taking you into the journey. So my friends, imagine that this is the shop where you have to give Maggie. This is the shop where you have to give the Maggie, right? I have to dedicate Maggie here. It needs X packet of Maggie. I don't know the value of X. But what I do know that if I will give X here, I will have to subtract X here. Then I will have to again add X here. Then I will have to again subtract X here. Then again add X. Then again subtract X. So that everything should get balanced. Now basically what I will be doing, imagine that you take one tempo from this position. We take one tempo from this position, an empty tempo. I hope you people understand the meaning of tempo. A carrier, goods carrier, automobile that carry goods. So basically we take a tempo, we start the tempo from this position. This tempo is empty. Now I will take this tempo and stop with this tempo at those positions, at those shops which have Maggie. Remember, I will not stop this tempo at those positions which do not have Maggie. It is unnecessary to stop this tempo at these positions which do not have Maggie, right? Because I want Maggie in the tempo so that I can give this Maggie to this shop. So I am taking the tempo from here. I will visit those shops which have Maggie, will collect Maggie from those shops as per the requirement, as per the necessity, and then I will return back to this position. I hope you people are getting my point. So remember guys, if you want to start from here and return to this position, the Modi method or the modified distribution method basically says that you have to form a loop. And every corner of that loop should have an allocated position. Now let us do not waste our time and start the tempo. So now I will start the tempo. I will take the tempo straight away to here. I will stop here. This is a position which has Maggie, which has allocation. Now I will take the tempo and move to this position. I will stop. I will again take the tempo, move to this position, stop. Now remember, tempo cannot go here. Tempo cannot go 7 to 6 because 6 does not have Maggie. I can only make stoppages at those positions which have Maggie. So I will be going to 2. And the tempo can make only right angle turns. It cannot move diagonally, right? This is one thing that you need to understand. The tempo cannot move diagonally. Now my friends, from 7 I am going to 2. Then stopping at 2 because it has Maggie. Then going to 1 because it has Maggie. Then again going to 6 because it has Maggie. Then I will straight away be heading back to the home or to my starting point. I hope you people are getting my point. So basically guys, I have formed a loop here. And check this out. Every corner, every vertices of this loop basically has a position. Every vertices of this loop basically has a position which has Maggie. So this has Maggie, this has Maggie, this has Maggie, this has Maggie, this has Maggie. Now you know what we can do. Just if this is plus X here, write minus X here, then write plus X here, then write minus X here, then write plus X here, then write minus X here. And at the last again we are getting back to the plus X. So now guys, basically what we have done, at the alternate positions of this loop, I have written a plus X, minus X, plus X, minus X, plus X, minus X. What this will do, plus X here, minus X here, this 20 will be balanced. Minus X here, plus X here, 70 will be balanced. Plus X minus X, 40 will be balanced. Minus X plus X, 30 will be balanced. Plus X minus X, 60 will be balanced. Minus X plus X, 50 will be balanced. Everything will be balanced. 150 packets of Maggi have been redistributed, reallocated. We are going to give Maggi to those places where I am writing plus X. Where I am writing plus X, we are going to give Maggi to those places. Where I am writing minus X, we will be taking some packets of Maggi from them so that a complete new solution can be obtained, so that plus X Maggi can be given to this position, which position is promising us that if you will give one packet of Maggi to that position, 1 rupee will get reduced from the transportation cost. I hope you people are getting my point. Hmm. Now, the important question. Up until this point, I know that I should be guys. First of all, let me explain everything to you. Why I am doing this, guys? I am doing this so that I can make you guys explain the modified distribution method. Otherwise, I would have just simply told you the steps. ठीक है ना? I would have simply told you the steps. This, or more easy. I would have taken the 630 solution, straight away performed the optimality test, would have proven to you that the solution is optimal. My job would have been over. But I am taking all the efforts, making all the efforts so that I can explain this to you. I hope you people are getting my point, right? I hope you people are getting my point. Now, my friends, now what? Now I know that where I should have to give Maggi plus X and where I should be taking Maggi. I am getting, but let's we go for 630. Minachi Sundaram, just concentrate, right? We will get to that point. Okay? It takes time, yeah. These topics are quite exhaustive, है quite exhaustive topics. LPP transportation as well as assignment, which I have to cover in the coming classes. These topics are exhaustive. But guys, do not ever make a mistake that let us skip them. They do not come in the GATE examination. They are very important with respect to the GATE examination. Let me just tell you guys this much. Sorry for that. Now. Suppose guys, these are the shops where you have given Maggi. Remember, this is also a place where we have given Maggi, but there is no minus X or plus X here, right? This will remain as it is. We have only made changes to the corner points of the loop. This will remain as it is. I am saying that these are the places that we have given Maggi. Now those places where I am giving more Maggi, suppose talk about this, I am giving more Maggi here, plus X, I am giving more Maggi here, plus X. Kushagra Vashist, after a long time I am seeing you, my friend. Very good evening. So these are the places, guys, that where we have to give Maggi, where we want to give Maggi, more Maggi. So they will not mind. Okay, you are giving us more Maggi, very nice. Put it inside my shop. But those places, my friends, where I am taking Maggi, from where I am taking Maggi minus X, I will have to make sure that I can take only that much Maggi, maximum, I can take only that much Maggi which I have given to them. I suppose you have given your friend 50 rupees, then the maximum that you can ask in return is 50. You cannot say give me 70. I hope people are getting my point, right? So I have given 20 packets here. So if I want to take X, X cannot be greater than 20. I have given 50 here. If I want to take X, X cannot be greater than 50. Similarly, I have given here 20, x cannot be greater than 20. I hope you people are getting my point. Now this x, my friend, is same throughout. This x is same throughout. Now one place promising me that it can return me 50. One is saying it can return me 20. One is saying it can return me 20. What can be the maximum value of x? What can be the maximum value of x? My friends, the maximum value of x will be 20, which is basically the least of those places which have Maggie and from where I have to take Maggie. So whichever places have a minus x, out of those places, the place that has the least number of Maggie, that will become the magnitude of x. I hope you are getting my point. So now I know that x is going to be 20. Now I know that x is going to be 20. Now I know that x is going to be 20. So I will make a new table. I will make a new table where I will be taking x as 20 and making the new allocation. So this 1 will get x, that is 20. This 2 will become 0. 4 will remain as it is, 30. 7 will get plus x, that is 40. This here 2 will become again 0. This 1 will become 30 and this 6 will become 50, my friends. So now these two places are 0. I will simply be deleting these two places. Because they are 0, I will be deleting these two places. Now guys, because x is 20, and this position has already told me that it will decrease the transportation cost by 1 rupee with respect to one packet of Maggi. With respect to one packet of Maggi, it will reduce the transportation cost by 1 rupees. And I have decided that I will give it 20 packets of Maggi. So 20 packets behind one packet 1 rupees. A total decrement of 20 rupees should be there. I have the solution at 650. Now 650 minus 20, I should be getting a new solution where the transportation cost should be 630. Now let us calculate this. Let us calculate this, right? Let us calculate this. 4 into 30. 4 into 30, that is 120, plus 7 into 40, that is 280, plus 120, 400, plus 1 into 30, that is 30, plus 6 into 50, that is 300, plus 1 into 20, that is 20. The total is coming as, guys, the total is coming as, one mistake I have done. I have not done minus x here. 50 minus x will be 30 here, right? Will be 30 here. Let me write in black. है ना? Now I hope you people are getting my point. So add all these, you will get z equal to 630. Remember, the optimality test has already told me minus 1 with respect to this position. And guys and girls, I have given x to 20 units. 20 rupees will decrease. So 20 rupees is getting decreased. This new solution is basically telling me that z is equal to 630. Okay? Now that moment has arrived where I am going to upset you once again. The moment has arrived, my friends, where I am going to upset you once again. You all are going to say, oh my god, what is going on? But let me tell you, guys, after all these efforts, I have now reached to 630, which I already had using the least cost method and the Vogel approximation method. But in order to explain this to you guys, I had taken 650. Now through the optimality test, I have obtained a solution where z is 630. Now the thing is that we have to perform the optimality test for this solution, because we do not know whether this solution is optimal or not. We do not know whether this solution is optimal or not. Guys, we can only find whether this solution is optimal or not when we will find Cj minus Zj. And for minimization Cj minus Zj, all values should either be positive or 0. No value should be negative. I have done this for this solution, 650 solution, but now I have to check again. I have to perform the optimality test again for this 630 solution. Are you guys upset? Are you guys upset? Guys, you better be. You better be. Why? Because this is going to stick in your minds. This is going to stick in your minds. One question, sir. Will your notes and PYQs be enough for whole industrial and OR? Kushagra Vashisht. It is more than enough. Not only for GATE. It is going to be enough for ESE also. For any competitive exam. DRDO, BARC, ISRO. I am teaching industrial and OR in such a way that any question in any examination, you guys will simply solve the question like that. I hope you are getting my point. It's not like I am being immodest or arrogant. I am telling this with confidence. I hope you people are getting my point. I hope you people are getting my point, right? Let me have a sip of water because I have to perform the optimality test once again. Okay, now we have to perform the optimality test for this one. So now guys, I want all of you to join me. Why? Because we have already performed the optimality test once. Now I will be asking you to perform the optimality test again. And basically I want all of you to join me so that we can revise together the entire optimality test and it should remain inside our minds forever and ever and ever. What is the first step? Check number of allocations equal to m plus n minus 1 or not. So guys, check this out, check this out, check this out. M plus n minus 1 is equal to 6. The number of allocations that we have 1, 2, 3, 4, 5. 6 is not equal to number of allocation. 6 is not equal to number of allocations. Now what? Are Kushagar Vashisht, what are you saying, man? My mother watches my classes. Do not say things like that in open. So, check this out. 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 Sir, can m plus n minus 1 be in fraction? No, Lalit Bhatt. It can never be in fraction because we are making allocations. There are particular cells. Either will I allocate something to that cell or I will not. So if I will count those allocations, they will always be integer. Okay? So guys, check this out. If the number of allocations are less than m plus n minus 1, then the problem is said to be degenerate. To obtain optimal solution or to perform the optimality test, an allocation of epsilon. What is epsilon? Negligible positive number. Negligible positive number is required at the independent position. Is required at the independent position. Is required where? At the independent position. I am saying epsilon and in my iPhone Siri is getting activated. Independent position. So these terms are very important. Degenerate. Whenever there is a degenerate problem, when m plus n minus 1 is greater than the number of allocations, or the number of allocation is less than m plus n minus 1, problem is degenerate. Whenever a problem is degenerate, we will require epsilon at what position? At independent position. I hope you people are getting my point. I am making these points, emphasizing on these points. Yes, Kushagra. Okay, pardon. Now, this is a case of degeneracy. Degenerate. Guys, something good has happened. ठीक है ना? Sir, can you provide lectures on MTBF, MTTR and reliability models for PI? Saksham, I will take your query and I will try, my friend, to provide the lectures of these topics not here on YouTube but on special class. ठीक है ना? Because in YouTube, my friends, we have already मतलब we get a schedule which we have to follow. So I cannot promise you on YouTube, but definitely on special class. And if I will do, I will inform my students through a schedule on YouTube, and then you will be able to watch those classes there. Okay? So guys, this is a degenerate problem. Whenever there is a degenerate problem, we need epsilon at independent position. At independent position. Why we are doing all this? Let us understand. Okay, na? Let us understand why we are doing all this. The thing is, my friends, the thing is that if I will write U1, U2, U3, V1, V2, V3, V4, right? If I will write U1, U2, U3, V1, V2, V3, V4, and I want to find the values of these variables. I want to find the values of these variables. Remember, I can take any variable as 0. Let us this time take U3 as 0. But if I take one variable 0, then also I have 6 more variables. And remember, to find the value of 6 variables, we need 6 independent equations. And these equations, guys, we used to formulate with the help of these allocations only. Like U1 plus V2 equal to 4, U1 plus V3 equal to 7. We used to do like this, right? But because there are only 5 allocations and there are 6 variables, I can only frame 5 independent equations, and 5 independent equations are not enough to calculate. 5 independent equations, my friends, are not enough to calculate the value of 6 variables. I hope you people are getting my point. So that is basically causing this problem to be a degenerate problem. That is what is causing this problem to be a degenerate problem, because there are not enough number of equations to find the values of these variables. So I need one more equation. Because there are 6 variables, 5 equations, I need one more equations. How I am taking these equations? How I am taking these equations? How I am taking these equations? Because they have Maggie. They have Maggie. They are basis variable. And these positions, my friend, these positions, they do not have Maggie. So I will have to provide epsilon number of Maggie. What is epsilon? Very small, negligible positive number, nothing basically. So it basically is asking me to add epsilon to one of these positions which do not have Maggie and take the coefficient of that position. So if I am writing epsilon here, it is basically asking me to take 2. And now it is asking me that through these 2, now you have 6 positions, and using this 6 position, you can find the value of these 6 variables. Are you guys connecting with me or not? Are you guys connecting with me or not? Now, it is saying that you simply cannot add epsilon anywhere. Epsilon should be at an independent position. What is the meaning of the word independent? Which do not depends on anybody else. Which do not depends on anybody else. If you have to find the values of these 6 variables, you need 6 independent equations. So epsilon should be added to an independent position. How to find the position? How to find the independent position? Guys, check this out. If this is plus x, then this is minus, plus, minus, plus, minus. So basically, if I will give any allocation to this one, 20, 10, 5, I have given 20 already. I am saying that if I will give, let's say, 5 more to this position, if I will give 5 more to this position, then 20 will become 25. Then definitely, my friends, these positions will get affected. Any change in this position will reflect here, will reflect here, will reflect here, will reflect here, will reflect here. I hope you are getting my point. So these positions are basically depending on each other. Any difference in this position will affect in all the other positions. So these positions, my friends, are basically dependent positions. They are depending on each other. Whereas I want an independent position. I want an independent position. So remember, my friends, in order to find dependent position, so that I can make plus x minus x plus x minus x and everything gets balanced out, in order to find independent position, I have formed this loop. I have formed this loop. I made sure that my tempo, once started from here, should again return back here. Starting point and ending point of the tempo should be same. But for which type of position? For a dependent position. For a dependent position. But I want independent. So for a dependent, if I am forming loop, tempo is returning. Then for independent position, my friend, tempo should not return. Loop should not be formed. Loop should not be formed. Loop should not be formed. Now check this out. Suppose I want to check for this position. I am starting the tempo here. I am starting the tempo from this point. Now remember, tempo should be stopped where? Tempo should be stopped where? Only to those places which have Maggie. Only to those places which have Maggie, not to these vacant spots. I hope you are getting my point. And my friends, tempo cannot take a diagonal move. Tempo cannot move diagonally. It can only move in right angle. It can only move at right angle. I hope you are getting my point. Okay. So let me start the tempo from here. If I will start the tempo from here, I can either go here or I can either go straight away here. Two options are there for me. So now let us go to this position 4. From 4 I can go to 7. Now from 7, where should I go? From 7, where should I go? From 7, where should I go? Guys, I cannot move anywhere else because the tempo cannot move diagonally, and I cannot go here, I cannot go here, I cannot go here. All the other places do not have Maggie. I have to only make a stop at those positions which have Maggie. Ashwin is saying really critical. Ashwin is saying really critical. Ashwin, tell me, my friend, have you understood that for an independent position, loop should tempo accident? Guys, have you understood that for independent position, we need the position in such a way that tempo, once started from this position, it cannot return back. Loop should not be formed. Loop should not be formed. So guys, I have taken a route in this way. I cannot move anywhere else. Tempo is stuck. If I start from here and go straight away here, then here, From this point, I can literally not go anywhere else. From this point, literally, I cannot move anywhere else. What is the meaning of this? It means that this position is an independent position. Saksham Rathore has written something. Saksham, I will get to your point. I will get to your point. Basically, Saksham is saying that at the position 2, 3, second row, third column, here we will add an epsilon. ठीक है ना? I will not add epsilon there. Saksham, let me clarify. I will not add epsilon there. Just see, wait and watch. Right now, I have confirmed that this position, my friend, is an independent position. ठीक ठीक. Now, for your sake, I will check more positions. I will check more positions about their independent or dependent nature. So now let us check about this. Let us check about this. Let us check about this. Let us check about this position. So guys, if I start from here, sorry, what has happened? What has happened? Sorry. So, suppose I start from this position. I can go here, then I can go here, then I can go here, then I can return back here. I hope you are getting my point. From this position, my friend, I can go here, 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 and then can return back here. So, is this position independent position? No, my friend, it is not an independent position. Loop is forming here. This is not independent. You cannot add epsilon here. Let us take this position. From this position, I can go here, 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 then I cannot go anywhere. Let's say again I check from this position. I can go here, here, and then I cannot go anywhere else. So again, this position, my friend, is an independent position. Let's check for one more position. Let's check for this position. I can go here, 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 then I cannot go anywhere else. If I go here also, then here, then I cannot go anywhere else. So this is also an independent position. Let us check this position. I can go here, 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 then nowhere. I can go here, here, then nowhere. So this is also an independent position. Let's check about this position. I can go here, here, then nowhere. Here, oh, here, then nowhere. Here, then nowhere. I hope you are getting my point, right? So this is also an independent position. Now let's check about this one. Here, here, nowhere. Here, here, nowhere. Here, then nowhere. So this is also an independent position. Remember, loop should not be formed. Always remember, loop should not be formed. Guys, although this question is taking us quite a long time, but guys, through this one question only, we are basically understanding the entire modified distribution method. I mean, if this question would not have been there, if I would have taken 630 for the solution, for the optimal solution, within 2 or 3 steps, I would have proven the optimality test. Come on Ashwin, why are you joking? Within 2 or 3 steps, I would have proven the optimality test, optimal solution. Things would have been okay for me, but you would have suffered in examination. So basically, with one question alone, I have explained you how a solution is not optimal, then what to do in order to get another feasible solution, again perform the optimality test for that, and I am also dealing with a degenerate problem, epsilon situation, for which I would have solved another question in order to explain to you guys. I hope you are getting my point, right? I hope you are getting my point. Now my friends, I have located the independent positions. I have located the independent position. Now, epsilon can be given to any of these independent positions. Now, please check this here. It is written here that epsilon, if more than one independent positions are available, then epsilon can be added to the cell where the cost is minimum. Where the cost is minimum. So out of these positions, what is this? Okay. So out of so out of these positions, my friend, out of these positions, these right marked positions, epsilon should be written in that cell where the cost is minimum. So cost is 2347 2 6. So out of these, this 2 and this 2 are having the least prices, least transportation cost. So epsilon should be added here. But I am giving you guys a shortcut. I am giving you guys a shortcut. I am saying that epsilon can be added to any of the independent position. You don't have to bother about this minimum or maximum. It is baseless, useless. I have solved hundreds of problems. Guys, I have solved hundreds of problems. And remember, I as a teacher try to scrutinize each and every step so that I can explain everything to you guys. And I am saying that no need to check this minimum maximum. You can simply add epsilon at any of these independent position. Now you can see like this is 7, hai na? This is the maximum of these cells. This is the maximum of these cells. Maximum transportation cost of the entire cell, 7. This is an independent position. I will add epsilon here. I will add epsilon here. I am going against the method that is mentioned in the optimality test, but I am going to add epsilon here. So now I am going to write epsilon here and I am going to write 7 here. Correct? Correct? Now guys, what I can do? Now what I can do, I can find the values of these variables. I can find the values of these variables. So u3 is 0. u3 plus v1 is equal to 1. u3 plus v1 is equal to 1. So I can write v1 is equal to 1. Now what? u1 plus v1. Sorry, I cannot find this. Then if this is 1, this is 0. So now this is 0 and 4 is equal to 6. 0 plus v4 is equal to 6. So I can write 6 here. Then my friends, this plus 6 equal to 1. This plus 6 equal to 1. So this is minus 5. I hope you are getting my point, right? I hope you are getting my point. Then my friends, then what? Then what? Arey, tell me then what? 0 plus v3 equal to 7. 0 plus v3 equal to 7. So v3 will be equal to 7. Then my friends, u1 plus 7 equal to 7. u1 plus 7 equal to 7. So basically I can write u1 equal to 0. And if u1 is 0, v2 equal to 4. So these are the values that I am getting. These are the values that I am getting. These are the values that I am getting. Now what to do next? What to do next? I hope this is going to be the end of this solution. I hope this is going to be the end of this solution. So 0 minus 5 0 1476 1476. Now guys, basically I will be writing zj now. What is zj? What is zj? Those positions which do not have Maggie, those positions which do not have Maggie, which are non-basis variable, I am going to check that whether out of these any non-basis variable there is any Dhoni or Kohli which can further minimize the transportation cost. So guys, these are the positions which have Maggie. These are the positions which have Maggie. Now I will be writing zj for these positions. So 0 plus 1 1, 0 plus 6, 6, minus 5 plus 1, minus 4, minus 5 plus 4, minus 1, minus 5 plus 7, 2, 0 plus 4, 4. Now I will be calculating Cj minus Zj. I hope this will be the last table that I draw for the optimality test of this question. This is the last table that I will be drawing for the optimality test of this question. So guys, let me draw the original matrix here, the Cj matrix. Let me draw the original Cj matrix here so that I do not have to look backwards. So 2, 4, 7, 6, 5, 3, 2, 1, 1, 4, 7, 6. So 2 minus 1 will be 1 here. Then minus 4, sorry, 5 Cj minus minus 4. This is going to be 9 here. Similarly, 3 minus minus 1, 4 here. 2 minus 2, 0. 6 minus 6, 0. Then 4 minus 4 is also 0. So congratulations guys. Congratulations first of all that you all went through the entire optimality test, and now guys we have basically dealt with every condition out there under the modified distribution method. So a very big congratulations to all of you, because let me tell you one thing very honestly, when I was preparing for GATE in 2014, I literally left this entire chapter. This entire topic, especially this modified distribution method, because at that time I felt that it is impossible for me as a human being to learn this. But guys, you people have made it through. Give a big tap to yourself right now, because let me tell you, understanding the modified distribution method is really an achievement in itself. So congratulations first of all. Why I am congratulating you? Because guys, Cj minus Zj, minimization problem, transportation problem is a minimization problem. All the values in the Cj minus Zj are either positive or 0. That means there is no other positions where I can add Maggie and can further minimize the transportation cost. There are zeros which are clearly indicating that this problem is a case of multiple optimal solution. Why? Because they are saying that if you will give Maggie to us, solutions will change, allocations will change, you will get a new solution. But the overall transportation cost will not change, my friend. The overall transportation cost will not change. I hope you people are getting my point. So this problem, let me write this, is a case of multiple optimal solution. This problem is a case of multiple optimal solution. Right. I hope you are getting. So this is the final solution. 4 into 30, 7 into 40, 1 into 20, 1 into 30, 6 into 30. Guys, you can check that using this method we have got the same solution. So this 630 is basically an optimal solution. If we would have taken 630 initially from this position, just by having 3 matrix without doing anything, complete optimality test would have been done. But in order to explain this to you guys, I have taken 650, then I have reached 630, then the degeneracy case was there. So loop formation, no loop formation, everything I had to explain with a tempo example, and then we have reached to the conclusion. So that's it. That's it for today's session. That is all for today's session, my friend. ठीक है ना? I will be ending the class now, and tomorrow, my friends, there will be the last class of transportation problem where I will basically be dealing with this question. है ना? An ultimate question in the entire class. I will be solving only this question, where I will basically be revising everything for you guys, so that everything can be revised again, so that everything can get stuck in your mind. So in the next class, I will be solving only this question alone. And then day after tomorrow, I will be starting a new topic, a new chapter. I hope you are getting my point, right? Saksham Rathore, let me tell you guys, Saksham has asked a beautiful question. Saksham has asked a beautiful question. He is basically asking that, sir, can we apply this modified distribution method to any of the solution? Are Saksham, I have applied it to northwest corner method. I have applied it to northwest corner method. You can take any of the feasible solution literally and perform the optimality test. But guys, let me tell you, whenever you get a transportation problem, solve the transportation problem with all the five methods. With all the five methods. Why I am saying this? Because my friends, let's say you chose some method like rho minima and you obtained 650. So that will basically lead you to these number of steps from the optimality test. You will get frustrated down there in the examination hall. Correct? So it is recommended by me that you basically use all the five methods and find the feasible solution. Because let me tell you, any of the five methods can provide you the best feasible solution. In this problem, Vogel approximation and least cost are providing a 630, but column minima is providing a 750. It doesn't mean column minima is bad or Vogel approximation or least cost is better. They all are basically providing us feasible solution. In some question, column minima can provide us the best solution, 630, whereas least cost and Vogel approximation can provide us 750. I hope you people are getting my point, right? I hope you people are getting my point. So guys, from my side, it is advisable, use all the five methods to find the feasible solution, then take the best out of the lot and perform the optimality test. Thank you, Saksham. Thank you for this question. I got the opportunity to explain this to my students because of you. Thank you, my friend. Now, in the next class, I will be basically dealing with this one question. Guys, कल संडे है तो क्लास है यूट्यूब पर. यस, ध्यान देव कुरहड़े, टुमारो इज गोइंग टू बी अ क्लास. टुमारो इज गोइंग टू बी अ क्लास. ठीक है ना? I will only take a single hour session, 1 hour session, where we'll be solving this question. But guys, let me tell you, if you will invest 1 hour tomorrow in my lecture, I promise you guys that after that, you will never have to solve another problem from transportation problem matrix. From transportation problem, you will never have to solve another problem. This one problem will basically do everything for you. So tomorrow session, 9:15 p.m. sharp, attend this problem. Trust me, it is advisable to do because there is a very small concept that is left, converting a maximization problem into minimization problem. This problem will basically deal with that concept also. ठीक है ना? So guys, now time is already over. I have got various messages that stop the session. So guys, you already know about the manufacturing 2020 series, है ना? Where in 20 days time I am targeting the entire manufacturing by investing only 2 hours, 120 minutes daily. What's weightage of industrial in PI? Saksham Rathore, industrial is very important from the PI perspective. Around 13 to 15 marks are there. ठीक है ना? So it is a very important subject. It depends, and the range varies in GATE examination. So consider like 10 to 15 marks. Now, guys, let me tell you, Unacademy is going to start a new batch for GATE 2022 aspirant. The name of the batch is Evolve. It is going to start on the 28th of December. The batch is going to be both in English as well as in Hindi. The legendary educators on the Unacademy platform are starting this batch on the 28th of December, and later other educators will also join this batch. so that they can give you the best they have. Remember, if you want to join this batch, you can use the referral code M10. This code, my friends, can fetch you a discount of 10% on the Unacademy Plus as well as on the Iconic subscription. Another batch is going to start for GATE 2023 aspirants, that is the Ascent batch. This batch is also for mechanical students and it is also going to be in English as well as in Hindi. And this is also starting on the 28th of December. The same educators are going to be in charge of this batch, right? These are the legendary educators on the Unacademy platform. Their ranking is among the top 10. Right now, my ranking is 90. ठीक है ना? So I am still to catch them. I am new to the platform, but I know that with the love and affection that you guys are showing towards me, I will definitely reach to that milestone someday. And I know that I will reach there. Definitely I will reach there, and I know I can prove myself within 6 months of time. Guys, remember, use the referral code M10. This code can fetch you a discount of 10% instantly across the Plus as well as on the Iconic subscription. Okay, now let me just explain this to you. That why you should be going for the Plus or the Iconic subscription. Remember, guys, opting for the Plus subscription, it is like an investment. It is not like you are just giving money. It is an investment. It is going to show its value in future. Number one thing, you can attend n number of live classes in Hindi as well as in English. Number two, you can join multiple batches. Like if you go to a coaching institute and they put you in one batch, and if you do not like some teacher, your entire year is basically wasted. But here on the Unacademy platform, you can join multiple batches through one subscription. You can join like hundreds of batches, rank improvement batches, question series batch, then legendary educators batch, all stars batch, different batches are there. So whichever teacher you like, suppose you like me for industrial and OR and I am in some batch, you can join that batch and can study industrial OR from me. The entire schedule is going to be there. I will be teaching you guys live. Okay, and let me tell you, my friends, the Unacademy platform is highly interactive. Live interaction is there. Suppose I am teaching you, then every word I am saying will be getting to you or reaching you live, not like YouTube where there is a lag of 30-40 seconds. Then through the comment section, you can ask your questions. I can read the comments live in my class. I do not have to take another smartphone like this where I am trying to read your comments. Then my friends, polls, leaderboards are there. Then there is a separate section for question where you can take a screenshot or you can take a photo and can straight away upload it through the app. That question will be shown in front of me. I can answer your question through that. I hope you are getting my point. So this Plus platform, this Plus subscription is basically designed to make you as competitive as possible in the GATE examination. There is a provision of crash courses here. Every week there is going to be a test. Every fourth class is going to be a doubt solving class. So all these benefits are there, my friends, and you can literally take the advantage of these benefits and can become extremely competitive for the GATE examination. The Iconic package, on the other hand, is one step ahead. Unacademy is basically providing you with a personal coach who will be planning your study sessions, who will be giving you study booster sessions, who will be personally analyzing your tests. Unacademy team is going to provide you with the preparatory study material, so you don't have to dig anywhere else, don't have to go anywhere else. Everything is here only. My friends, let me just tell you that the Plus subscription comes in variety of packages. It comes in 1 month, 3 months, 6 month, 12 month, 18 month, 24 month. My suggestion is that if you are going for GATE 2022, take the 18-month subscription. If you are going for 23, take the 24-month. Now you must be having a doubt, sir, why not a 12-month subscription for 2022 batch? 1 year is away. Guys, remember that after the GATE examination, there are other examinations also, like DRDO, ISRO, BARC, SAIL, NTPC. They are also conducting their own exams. And they are basically after the GATE examination. Correct? So if you want to study for those examination also, then this 18-month package will be fruitful for you. and just see the difference. Like the 1 month class is basically costing us 5500, whereas the 18-month class is costing us 2139 rupees, and the 24-month class is costing us 1833 rupees only. So if you will convert, you will find that this is like 50 rupees per day and this is like 60 rupees per day. Extremely economical, my friends, extremely economical. Nowhere in this country can any institute even match this value. Okay, and one more thing, if you will use the referral code triple M10, in the referral code section, if you will write triple M10, then guys, this 38,500 and 44,000 will basically become 34,650 and 39,600. So 10% instant discount, 10% off using the referral code triple M10. I hope you are getting my point. The same goes for the iconic subscription. Same goes for the iconic subscription. Iconic subscription, my friend, for 12 months is costing 5250 and for 24 months it is costing 74,000. But if you will use the referral code triple M10, if you will use the referral code triple M10, then 10% discount. This 50,000 basically becomes 45,000 and this 74,000 becomes 66,000. ठीक है ना? So 10% discount on the iconic package also, right? Friends, I will not take much time. Let me just tell you that the YouTube channel that you are watching, it is basically the #1 YouTube channel in the GATE and ESE mechanical category in the entire country. It is India's #1 team for GATE and ESE mechanical, the Unacademy GATE mechanical team. It comprises of Devendra Negi sir, Pallav sir, Aproop sir, Alok sir, myself, Manish Mishra, Sandeep sir, Prakhar sir, and Vishwajit sir. All of these educators are top in their category. Top in their category, my friends. And if you want to be a part of this Unacademy team, if you want to connect with this Unacademy GATE team, just simply scan this QR code. You will be able to join the Telegram channel of the Unacademy GATE mechanical team, where every educator is providing the PDF and notes of their classes, and they are basically interacting with the students and letting them know, providing them the notifications of their classes. So guys, that is all for today's session. Thank you all for watching me. Please like, share and subscribe. And remember, I will see you all tomorrow at 9:15 p.m. on YouTube. And do not miss the morning 9 a.m. session on the Unacademy special class, Manufacturing 2020. Stay tuned. I will be coming back. Bye-bye. Take care.